In this video, I will be talking about formulating discrete distributions. Now, I'm taking an example from the book where we look at the sum of two dices. Now, an important question to answer is how many possible outcomes are there? So, to calculate the possible outcomes, what we have to do is we have to take the possible outcomes from the first dice and then take the possible outcomes from the second dice to form our table. And now what we do is we take this value and then add it to this value, which would give us a formula that can help set our table up. Now, from looking at our table, we see that the values range from 2 to 12. So just take this, get that, and then now you can take the frequency to be count if. We take our range to be this table, then we take our criteria to be this, and then take our criteria to be the x value, we get our frequency, we drag it down, and that gives us the frequency of each sum. Now, to find the probability mass function, we're basically just looking for the probability of the value itself. So now, before we do that, we need to figure out what's the total number of outcomes that we have. Now, to find the total number of outcomes, we just take count, and then we put that formula down, which gives us 36. So now our probability would be frequency over 36, which is, and that gives us our probability. We drag it down, and that gives us the probability mass function for each x value. Now, to find our cumulative distribution function or our cumulative probability, we would take, for the first value, we would just take this as it is, and from the second value, we would take the value above and then add it to the value on our left, and we would just drag this down. So that would give us our discrete probability distribution table. Now, we can use this table to find out the probabilities of certain sums in this case. So the probability of getting the sum of 4 in this situation would be 0.08, as we can see from the table. The probability of getting a probability of 4 or a sum that's less than 4 would be 0.17, and then the probability of that going in the other direction, which would be the probability of getting something that sums up to be more than 4, would be 1 minus the previous value. Now, moving on, we have expected value, which is the mean of our data. Now, to calculate the mean, what we would do is we would do sum product, and then we would take our x values, and we would take our frequencies. That would give us the expected value of 7. So for our data set, the expected value is 7. Variance is we use variance basically to judge the uncertainty of our data, and normally we calculate variance by taking the square of the standard deviation of our data. So we put this in brackets since we're going to square it later on. We take the standard deviation of our frequency and then square it, which gives us the variance of 2.82, and that pretty much covers discrete probability distributions.